Shortly, you'll be hearing from Jay, and he'll be presenting IEDB Query API, also known as the IQ API. So Jay, take it away. Thanks very much.
Sure, thank you. Let me just share my screen. All right, so hi, I'm Jay Greenbaum, and I'm happy to be able to share with you one of our newer features that we've developed called the IEDB Query API. And so I just want to start with what is an API and why does it exist? If you're not familiar with the jargon, an API stands for an application programming interface. And it's the goal is that it provides an alternative query interface to the IEDB, with the content being identical to what's in the web-based version, but the format is a bit different. And the ultimate goal of having this common interface for the web server and other applications. And so what I'm showing on the right here is how a typical user comes to the database, enters their search parameters, and gets a query done. And that query gets translated into SQL, which then hits a backend database server, and the query results come back to the user in the web browser. So now we're providing this alternative interface on top of that same database, but now we're using a technology called PostgreST, which allows us to expose the different tables as endpoints that users can query. So here they can write scripts against those endpoints or just make HTTP REST calls. And that hits the same backend database with the same content. The idea is that, or one of the longer term goals is to have the website also work off of that same backend. So now that you know a little bit about it, I want to explain how it works and how you can use it. So it all kind of starts with this base URL, which is in green here, so query-api.iedb.org. If you go to that URL, you'll be presented with a list of all of the available endpoints, so all of the tables that we make available. And so, as I mentioned, each of those database tables that you can query are a separate endpoint, so you can query against epitopes or T-cell assays or antigens and so on. And then you usually want to filter your query. So you usually aren't going to want everything returned. You're not going to want to retrieve all of the epitopes. Maybe you will, but most times you're going to want to target your query somehow. And that's done using PostgreST's expressive syntax. So you can add on to the end of your query the field that you want to query against, and then using PostgreST's search operators, you can say, I want to look for linear sequences that are equal to, which is what this EQ dot means, that are equal to synfecal. And that will then return all of the records from the epitope table that match that sequence. So when you put it all together, the URL becomes something like this, where we have our base URL, the table we want to search against, and any query parameters that we want to pass along. And this is what the response will look like. So you get a JSON response by default. You can also get a TSV response. You will have 3 rows or 3 records returned from this query, because there are 3 matching linear sequences. So we have kind of the base sequence in fecal, and then we have 2 versions with modifications. And you get the sequence plus all of the associated data for that record. Here, I've only actually selected a few fields to be returned. You would, without restricting the fields that are returned, you would actually get more. I'll show you that in a minute. But then you can take that same query, the same query parameter, so linear sequence equals synfecal, and do that same search against the T-cell table. And what this is going to do is now, instead of returning all of the epitope records that match synfecal, it's going to return all of the T-cell assay records where there was an epitope interrogated that had the sequence synfecal. So now you have one row per T-cell assay that matches that record. And so there are different ways to refine your query. So you can do horizontal filtering, where you can kind of shrink down the number of fields that are returned. By default, if you run this query, you're going to get more than 80 fields returned for each record, which might be overwhelming. It's probably going to be more than you want. So what you can do is to add on to the end of your query this select parameter. And what that will do is that will limit the number of fields returned per record. So here we're saying we only want to get returned the structure ID, structure description, source organism names, and parent source antigen names. And so instead of getting 83 records per field, 83 fields per record returned, we get only 4 fields per record. So it's a bit more manageable. Then you can also do vertical filtering, which is what you typically think about when running a query for specific values in a database. Again, if you search just the epitope search table, you're going to get more than 1 million records returned, which is probably not what you want, but you instead will want to filter that down somehow. So you search against a specific field. Again, I'm using the same example where we search against linear sequence. And now instead of 1 million records, we get the 3 that we care about. So PostgreST includes a bunch of different search operators by default, and they're all cataloged really nicely on the PostgreST documentation page, which is linked to here and also at the end of this presentation. But you can really get by with using just 2 of them. Will get you, for me, they work for about 90% of the queries that I want to do. And those are the EQ operator, which is what I've been using in the previous examples. And what this does is this allows you to search on string fields or numeric fields, so scalar fields that hold just one value. And they let you search for equality. So again, linear sequence, EQ dot synfecal searches against the linear sequence field, which is a string in the database. There are many tables where we have fields that contain list values. So for instance, in the antigen search table, we have a list of linear sequences, so linear epitope sequences that are associated with that antigen. And those cannot be queried with the EQ dot operator. So you need to use something called the contains operator, which is this CS dot. And it's a similar syntax. So you say linear sequences equals CS dot. And then in curly braces, you put the sequence, or you could even put a list of sequences that are comma separated that you're searching for. And then that will return all records where there's a linear sequences list that contains at least one record that matches the synfecal sequence. And like I said, there are search operators for many of the different database operations that PostgreST provides by default. So mathematical operations or comparisons like greater than or less than, like operations, so pattern matching, and yeah, it's really comprehensive and useful. And so the way that the tables have been put together, we allow you to reiterate pretty much the same queries across all of the different tables to recover the related information between them. So for instance, again, if we're searching the epitopes table for the synfecal linear sequence, the only thing we need to change to get the related information in the antigens table is just we're searching instead this linear sequences field for records that contain the sequence. And it's really similar syntax across all of the different tables. So that provides some convenience. And so why would you want to use the API? There are a bunch of different reasons, but it provides direct access to computer-friendly format, so JSON format, like I've shown you, which can also be human-friendly, and the real human-friendly format that you can plug into Excel, which is TSV, and you can do that without a web interface by just writing queries against an HTTP server. You can incorporate those queries into your code, and which will allow you to work with the data in the language of your choice. So there are many different packages for working with HTTP requests in all of the popular programming languages. And there are even specific packages for working with PostgreST directly. And then it would allow you to easily link between IEDB and other resources. And you can set up things like periodically rerunning automated queries for new or changed data. And you should be able to query just about anything that's available through the web interface. So that should also be available through the IQ API. If you do find yourself having a hard time replicating a query that's on the website through the API backend, let us know, because maybe we made a mistake and it's not available, or maybe we would just love to track down the reason why and help you out. So now that I've shown you a little bit about it, this is probably the best way to get started, or one of the best ways to get started would be to go to our documentation. So we use a system called Swagger that provides this interactive documentation of all of the different endpoints, so all of the different tables with all of the different fields that are available. And I'm going to now switch into a web browser and show you how that works. Okay. All right, so I'm at that URL that I had in the presentation. So this is our Swagger documentation, and it basically serves as a catalog of the endpoints that are available. I'll make this a little bit bigger for you guys. So you can see you can search the antigen table, and it provides a description of what's there. If you open it up, it's going to list all of the different fields that you can query, and each field has some documentation associated with it. And sorry, my mouse is freezing up. Let's use the touchpad. And so if we scroll down to the epitope table, we can perform that same query that I've been showing you over and over again in the PowerPoint. And so I'm just going to go ahead and type in Synfecal, and then scroll down this very, very long list of fields. So these are the 80 plus fields that are available in the table. I'm scrolling down to where it says execute. Sorry, this was faster with my real mouse. And I'm going to hit execute. And what this does is this actually runs a query against the backend live, and it should be giving me a response any second now. It's usually very responsive. And I seem to be having some kind of connectivity issue now. So, but what this would return, I actually wanted to demo how it would return an error code, because I didn't use the eq.operator. Yeah, so I'm having some kind of connectivity issue now. So I'm going to go ahead and just skip over to some of the use cases that we provide as well. So we do host a bunch of use cases over at GitHub, and we've made these available. Some of them available as Jupyter notebooks, and some of them as R Markdown documents. where we kind of show you some of the basics of working with the API backend, and introduce how these queries work. And I have a rendered version of the interactive documentation here, or the interactive use case here, where it just kind of shows you the basics of how to connect to the server, how to perform a search. So here you just enter your search parameters as a dictionary, and provide the table name that you want to search against, and you can fetch the results just using standard Python HTTP requests. And this was a big one here. So I'm just going to go back into my PowerPoint. Oops. And so this was what I was trying to demo to you in the documentation when I ran into the connectivity issue. So I would have entered this eq.synfickle sequence into the search box, which would be the same as when you enter the linear peptide equals synfickle on the IEDB website. And what you would get in response is, so it shows you the actual query that it, or the URL that it forms, and then it gives you a response as JSON. And like I mentioned, you can do this in just about any programming language. Here I'm showing examples of just using the standard HTTP request packages in a few different programming languages, Python, R, JavaScript, and so on. And it's really, really simple to write these queries against the PostgreST backend, and it's kind of fun. So where can you find more information? So I showed you the Swagger documentation. That's a really great place to start, because you can actually play with the interface there and test out your different queries and work things out. And then PostgreST also provides some amazing documentation. They've documented every little part of their system. So that's another great resource. And like I mentioned, we do host use cases at GitHub. We have probably 2 or 3 that are kind of contrived use cases where we're just kind of demoing different parts of the system and trying to familiarize people with how things work. But then we also have a couple that were actual use cases submitted by users that they couldn't figure out how to do something, like how to link between tables. And we were able to guide them through it, and then we just posted it as a use case for everybody to take a look at. So those are fun to have a look at as well. And then, of course, on our Zendesk instance, we do have a pretty in-depth help article that goes through some of the finer points and the idiosyncrasies of working with the API. And this is the team that's been working on it, and especially Kelly at Lighthouse has been really instrumental in getting this thing off the ground. And that's what I have for you, and I'd be happy to take questions. I just wanted to chime in and say that we resolved the issue with the query API. So it actually was not an issue with the API itself. It was my specific connection, and so everything is good.
Awesome. Did you want to re-show anything, Jay?
If there's a minute, I wouldn't mind just showing how fast it is.
Yeah, absolutely. We do have 2 minutes. That's for 7.
Okay. Cool. So let me make sure I'm sharing the right screen again. Okay, so this was where we left off when things were kind of broke down a bit. And so this was where we entered the linear sequence equals synfecal into the search box, and we clicked execute, and before nothing happened. Now when we click execute, it loads for a second, and then we get the response really quickly down below. It also shows us how to do the same query on the command line. So it will give us the curl command to do this. And then it will give us the URL. We can just take that and we can just paste it into the web browser. And we get this immediate response like that. So we can see, we searched for that synfecal sequence, and we have 3 records returned, right? Each with their 83 fields associated. And then again, just how you can limit that by adding the select parameter. So just say the structure, ID, and structure, description, right? And so it's just super fast and relatively intuitive and easy to use. But that was all the extra stuff that I wanted to show.